Okay, we're live. Go ahead.
Okay. Well, good afternoon. Hi. I am Brian Flynn, an ex-president of the American Academy of Environmental Engineers. And I am very grateful that we've got so many people interested in today's topic of discussion and have signed on online. Before we get started, I just want you to know that you can message your questions to Jay Banner, our speaker, Dr. Jay Banner, at the end of this discussion or presentation. We'd ask you not to use the chat feature during the presentation because I'm told that it interferes with it. And let me also give you a heads up that at the end of this presentation, we will give you Jay's email address if you have additional questions you want to send to him. And we'll also ask you to fill out a survey form. This is kind of a new program that the Academy has gotten into in doing these webinars. We want to get some feedback on it so that we can continually improve our processes and presentations. Okay, let me introduce Jay. Jay is the F.M. Bullard Professor in the Department of Geological Sciences at the University of Texas, Austin. Jay is a pioneer in the field of speleothem paleoclimatology. And Jay will once again berate me after this discussion, telling me that I didn't pronounce it correctly, but oh well. But it's a specialized field, but it's very important. He's basically done research over the years looking at formations in caves in order to extract from it basically climate data on rainfall going back hundreds of thousands of years. And as far as I know, it's basically the only way to do it. He's also worked on with his colleagues to come up with a global model for interpreting data from caves in terms of climate. He's the inventor of the Environmental Science Institute, and in turn, the environmental science degree that UT Austin confers on students every year. And this is a really great program. I'm very familiar with it. And I'll tell you, I know there's a lot of engineers in the audience. It is a hard science program, and it confers a Bachelor of Science degree. And if you work for employers that are using environmental engineers, these guys and gals that come out of Jay's program are very well suited for consulting engineering and working with other types of environmental organizations. Last, I'm going to point out that Jay is a founder and a leader of the Texas Water Climate Network, which is identifying data gaps in Texas's knowledge of this subject and then helping fill those gaps. And he's one of the authors of the 4th National Climate Assessment. So with no further introduction, let's go to Jay Banner. Dr. Banner, it's your turn to speak.
All right. Thank you very much, Brian and Marissa. I appreciate the invite to be here and to chat with you guys today about climate change impacts on water resources. I'll be focusing on an example from Texas, but what Texas is facing is kind of a combination of climatic change and demographic change that is coming to the rest of the country, the rest of the world. Texas will see it bigger, probably see it sooner. So it's a pretty good case study or test bed to see what our future may hold in terms of how resilient will our water resources be. So the main takeaways I want to offer you here are that Texas's climate has changed in the past, and it's projected to change in really unprecedented ways during the 21st century. And at the same time, the state's population is going to double. And this is going to drive synergistic impacts on many different sectors, resources, our quality of life, and we will need new ways in terms of research, education, policy to approach these interdisciplinary challenges. These are the main things I want to leave with you today. So I'd like to start, though, by talking about what does climate science predict will be the consequences of a warmer atmosphere. So we've seen that the atmosphere has been warming. The projections are it will continue to warm, and I'll share some of those projections with you. But this is now a widely accepted certainty that these changes are happening. So given that we will have a warming atmosphere, and if we continue using fossil fuels for our main energy source in what we call a business as usual scenario, the atmosphere will continue to warm and at a greater rate. So the question I want to pose is, what does the climate science predict will be the consequence of having a warmer atmosphere? And what these inferences and results I'm going to show you come from two main sources, but you can find it in many other places. I give you two examples of it here because I find these very good sources to use as a go-to resource about climate change. And at the end, I'll put up a slide that actually has links to these things. The Intergovernmental Panel on Climate Change, that they put out a report every 4 or 5 years. There's over 1,000 scientists and engineers work on that report, and also from the Fourth National Climate Assessment. So this is sort of like the global study that the Intergovernmental Panel does. The Fourth National Climate Assessment is a United States scale assessment of what climate change, what the best data are, what the changes will be, how it will impact our economy, our food security, and various sectors of our society. That 2018 study, as Brian mentioned at the outset, I was one of the co-authors of that study, one of 300. So I'll come back to that as well. So what will happen if there's a warmer atmosphere? Well, if the atmosphere warms, the ocean surface will get warmer. We'll have more evaporation over the oceans. That'll put more water vapor into the atmosphere. And more water vapor in the atmosphere will produce, on average, all other things being equal, more intense rain events. Secondly, if the atmosphere warms, there'll be more evaporation over land. There's more evaporation over land because the land surface is warmer. Any drought that might not actually turn into a drought might become one. Any drought that would have happened otherwise would be longer and more intense in terms of the dry periods we can expect. And all of these things are obviously going to have direct impact on our water resources. Thirdly, with a warmer atmosphere, we're going to warm the temperature of the ocean surface. So with higher sea surface temperatures, climate science predicts that there'll be more intense tropical storms and hurricanes. So these are things we could just step back and say, this is that there are things about climate change that are uncertain. There are things about climate change that there is debates about. What's the cause? What's the best path forward in terms of addressing it? But it's often important to step back and say, what are the things we know for sure and with some certainty? And these generalized statements here are simply following, the laws of physics, and as it relates to our climate system. Nothing more, nothing less than that, right? And they have been borne out over time to be very consistent inferences we can make based on all the data in these reports that you could find. All right, so given that, now I'm going to ask you to conjure up in your mind's eye what North America looks like from space. And it'll help, go ahead and close your eyes and imagine, you're on the space shuttle flying upside down and looking down on Earth. You're flying by North America. What does it look like to you? Or you're Sandra Bullock hanging off the space station in that movie. It was that movie, Gravity. Yeah, and you're looking down at the Earth as you're falling down and making a soft landing like Sandra Bullock did. She survived that. In any case, does it perhaps look something like this, what we see here? Hopefully you could see my cursor, but what we all intuitively know about the U.S. is that the southeast U.S. is lush and green, and the vegetation is healthy because it's humid there. As we transition over to the southwestern U.S., we see in our mind's eye, I'm sure you've all came up with this, that it's actually not as green. It's brown or it's white, and the vegetation is not doing as well, or it's just not as abundant, right? So it's sort of a transition from the humid southeast to the arid southwest. And that transition almost goes, if you draw a line, almost right through here, and this turns out it's going right through Texas. So for those of you familiar with Texas, This line right here on the landscape is the Balcones Escarpment. This is Dallas-Fort Worth. This gray area up here, it's Houston, San Antonio. And as this Balcones Escarpment or Interstate Highway 35 is one line, and then here's the Colorado River, the little Colorado River, runs through Texas, not the one in the southwest US, and makes this big X marks the spot. So that's where Austin is. Austin seems almost at this transition between the humid to arid, southeast to southwest US. But it's actually somewhere a little bit further west of Austin. And it's actually someone over 100 years ago actually said this line of 100 degrees west longitude is a good demarcation of that boundary, that wet-dry boundary as we go from east to west across the US. And it's sort of a continental scale boundary. And it's not a sharp transition zone. It's not like you drive out there and step outside of your car and spread your feet apart and say, my right foot's in the wet zone and my left foot's in the dry zone. It's more of a transitional zone, of course. But on this scale, it's actually a fairly sharp boundary. And we'll come back to this concept of this 100-degree west longitude line. It's also known as what we call it the 100th meridian. Right? So we'll keep that in mind. Now what I would like to do is get a little bit closer here. We're just going to focus in on Texas. You can see the outline of the state here. Again, this is satellite data giving us these different colors here. And without getting into normalized difference vegetation index, it's a way to use satellite data to see where the vegetation are healthy and where the vegetation are not healthy. It has to do with how when vegetation is actively photosynthesizing, it absorbs and re-radiates radiation coming in from the sun at different wavelengths and intensities. And so satellite scientists, remote sensing scientists, are actually able to use this to get this picture of vegetation health. So this is the end of August 2010, August 29th, 2010. We can see that the green colors indicating the healthy vegetation are here in East Texas, and the brown colors indicating not so healthy vegetation, or the white colors indicating absent vegetation, are on the western part of the U.S. And the 100th meridian, this 100-degree west longitude, comes right down off the eastern line of the Panhandle, right like this. So now, even on this smaller scale, you can see that's a pretty good line that was drawn over 100 years ago to say this is the boundary. So basically, this shows us that Texas is sitting right on that transition zone between the humid southeast and the arid southwest parts of the United States. So this is the end of August 2010. I'm going to roll the clock forward 365 days, go to the same date in 2011, and we'll see. And so that's it a year later, and you could see this dramatic shift. Almost the whole state is now plunged into this intense drought. It was a historically intense drought, the most intense drought on record in the history of the state. It lasted a few years. We call it the drought of 2011 because that was the most intense year of that drought. It caused quite a bit of hardship. We'll go into some of it later. There were a lot of economic costs to it as well, agricultural, livestock, etc. Pretty dramatic change. And we go back and forth. So usually when I show this, and before pandemic, and I was speaking to live audiences, I would often hear audible gasps and oohs when I would go from here to here. Yeah, and I know we don't have the technology, so I'm just not hearing them now. But just go ahead and let it out if you think this is a dramatic change. All kidding aside, yes, this is a very dramatic change. And I believe Brian and Marissa, I have until 1 o'clock, so I could just sit here until 1 o'clock and go back and forth like this. But no, I'll go on. And point here being that this was a pretty pronounced shift of that wet-dry boundary. It shifted dramatically to the east, and it stayed there for a few years. I'm going to show you data that suggests in the past that this shift happened for longer periods of times at higher intensity. And in the future, it's going to happen at unprecedented levels in terms of the length of time and the intensity with which it will shift. And this is, you'll see in a minute, why this is going to be so important for the state of Texas's water resources. So The dude who came up with the name, the 100th Meridian, was John Wesley Powell. He coined this term. He was a professor of geoscience at Illinois Wesleyan University. If you wanted to visit him during his office hours, you probably couldn't find him because most of his time he was doing research all over the Western United States, mapping it, taking inventory of lots of things. He was the first person to lead a research trip down the Colorado River, the one that goes through the Grand Canyon. He was the second director of the U.S. Geological Survey, the founder and first director of the U.S. Bureau of Ethnology. He was, and imagine, he came up with this view of what our country was facing, and he was so concerned about it that there was this really dramatic change as we went across the 100th meridian that he would say we should not be developing the land to the west of the 100th meridian. Why? And he would go to Congress and say things like, gentlemen, you're piling up a heritage of conflict and litigation over water rights because there's just not enough water to supply the land. He said we should not be developing the land to the west of the 100th meridian because the water resources cannot support civilization being developed out there. As I said, he talked to Congress, he talked to others. He had a lot of creative ideas about how water resources should be developed, a lot of prescient ideas. Unfortunately, at the same time as he was making his case, Congress also was listening to the input from some major corporations like the major railroad companies. And the major railroad companies, in exchange for building the railroads, were given hundreds of millions of acres of land in the western U.S. So they had a vested interest in seeing that land developed because it would make for more income and more need for the railroad system. So they listened. They, being Congress and the policymakers, listened to the latter rather than the former. They did not listen to John Wesley Powell, as you know, because we've developed such meccas of Western civilization, such as Los Angeles and Las Vegas and places like that. We know that this has been developed, but I guess it's satisfying that here we are, about 150 years later or so, to know that no longer do we have to worry about 150 years later the undue influence of large corporations on how land is developed in this country. Okay, that was said facetiously. I'll now move on back to telling you a little bit more about John Wesley Powell. He was really quite a Renaissance guy. He was an officer in the Civil War. There he was in the Battle of Shiloh, giving the order to charge with his right hand, and it got shot by a musket fire, and he lost his right arm. There you can see it missing in the photo there. That's John Wesley Powell on the right. Remarkable as he was, he healed up and he re-upped his service, joined the forces again, and there he was in the siege of Vicksburg. Now, in like any good geoscientist, he was hunkered down in the trenches and looking at the strata on the walls of the trenches because of his geoscience background. I think he was so far ahead of his time in terms of thinking about water resources. We might take perhaps fashion tips from him since he was so far ahead of his time. You could see this hipster facial hair rivals anything you might see today. And I think the next big fashion forward thing, seeing how forward looking he is, I would go out and I'd be buying up pairs of pants that had the waist a clear 14 inches above the belly button. I think that's going to be the next big thing. All right, so enough with my romance with John Wesley Powell. Let's move on. So the 100th meridian was this phrase he coined, and we use it here. This is the title of our proposal we sent to the National Science Foundation to study this issue. And you can see here is the 100th meridian, right? There's that wet-dry boundary. And what you can see in shaded in gray here are counties with greater than 75% population growth projected to occur by mid-century, right? And look at this line here from Rio Grande Valley, RGV, San Antonio, San Marcos, Austin, Dallas, Fort Worth. I think Texas has 4 of the largest cities in the country. I think 8 of the fastest growing cities. A couple of years ago, San Marcos was the fastest growing city in the country. That's right between Austin and San Antonio. So look at this within this red field here. Look at this subparallel line to the 100th meridian, that if the 100th meridian does move and does shift to the east, what's going to be this confluence of synergistic negative impacts will be if that line moves there. That means we'll have much lower water availability. If the population grows as projected, we're going to have much higher water demand. And the projections by the demographers are not only would our state's population double, but about 90% of those new Texans will be moving into these cities. So we're going to have twice as many people and much less water. And we'll talk about how our state may or may not be planning for this. But let's go through some of the data that indicate how things have been in the past, how they are today, how they will be in the future in this region. And going back to that satellite image, as I said in your mind's eye, I'll just go back here really quick. One thing about Texas and where it's located, think about it. It is part of the arid Southwest, so it gets the climate impacts of these extended droughts in this region, and it's also sitting on the Gulf Coast. So it gets the intense tropical storms and hurricanes and flooding that are associated with this part of the world as well. So Texas is sort of sitting in a climate bittersweet spot. It's kind of got the double whammy of these climate change impacts, as well as the triple whammy of the rapid population growth. So I want to go through a little bit of terminology here. When we talk about how climate changes through time, we could talk about present climate. We refer to that as the instrumental record. What are the instruments we're talking about here? Thermometers, rain gauges. They go back to about 1880. All right, about 140 years of record we have. Back before there, the record keeping wasn't very good. The instruments weren't good, or they weren't invented, or people didn't care to write down. They didn't think, let's start recording everything that happens every day because it might be useful in the future. So back before the instrumental record, we need to look at these proxy records for when we don't have the instruments. We have to have a stand-in for the instruments. And for that, we use sedimentary rocks, corals, ice cores, speleothems, as Brian said at the outset. I'm going to focus today on tree rings, another way we can reconstruct past climate, right? So these are all layered deposits of minerals or organic matter that we can tell time on, and they record something about the climate in the past. And we'll go through that in some detail here for tree rings. And then when we talk about future climate, we're talking about model simulations. So complex numerical codes run in many cases by high performance supercomputers, right? And what these models do is they simulate atmospheric circulation, right? We know about what's driving atmospheric circulation. We could quantify that, put equations of mass, momentum, etc., into a computer code, and then we could change future conditions. We could say, well, on this trajectory we're on, here's how much greenhouse gas concentrations there'll be by the year 2030, 2040, 2050, etc. And we could say, how will the temperature change in response to those elevated levels? How will that change in temperature influence atmospheric circulation? How will interactions between the land surface and the atmosphere shift atmospheric circulation, etc.? Put that all together, spin the model up, and toggle the conditions, dial up, different scenarios for how carbon emissions will change in the future. And this is a very useful tool for seeing what the bounds are for possible changes coming forward. So that's how we look at future climate. All right, so when we look at past climate, as I said, one of the big things we use are tree rings. You probably all know how this works, right? The oldest rings, if you look at a tree stump, the oldest rings are in the middle, the youngest are at the margins, and then the bark. This is just a cartoon. Let's look at something actually real. This is a microscopic slide through a sequence of tree rings. The oldest part of the tree is on the lower left here. The youngest part is on the upper right. I'm going to walk through this succession as we go younger and younger, and you tell me to stop when we get to the wettest part of the record.
There.
All right, there. Very good, Brian. So Brian represents about 2% of all of you watching. I'm going to extrapolate that 100% of you are just like Brian. He got it 100% right. And as you all know how this works, right? Where the rings are thicker means that there was more abundant moisture available. Where the rings are thinner, they are much more water impoverished. Okay, so that's how it works. It's a proxy for past wetness. Before we step further backwards in time, let's look a little bit forwards. What is Texas looking at this century? Here are model projections for the late 21st century. So for the last decade of this century we're currently in, And this comes from that report that I mentioned I was one of the co-authors of, the Fourth National Climate Assessment, which came out a few years ago. On the left is the low emission scenario, on the right is the high emission scenario. So these emission scenarios are based on how we use energy, right? How we use fossil fuels. And if we continue in our business as usual scenario, in other words, continuing to use fossil fuels the way we have always used them, this is what's called a high emissions or business as usual scenario. This one on the low emission scenario is if we undertake a series of actions, innovations in renewable energy, transitioning away from fossil fuel to a more renewable based economy, international accords and treaties to ensure that this takes place. Actions by individuals, actions by corporations, actions by government. That's the low emission scenario. And so you can see on the scale here on the bottom, the change in number of 100-degree days. What does that mean? That means compared to today, how many more days a year will it be? How many days a year will it be 100 degrees or warmer? Okay. So what this says, if we look at the high emission scenario, if we look at Central Texas, like Austin, like right here, we're right on the boundary of somewhere around 70 to 80 more days. Well, what I remember, I didn't see the data for last summer, but for the summer before, we had 52 days, I think it was, somewhere between 50 and 55. Let's call it 52 days where it was 100 degrees or warmer in Austin. That was 2 summers ago. So what this says is we'll have 70 more of those, right? 120 something days where it's 100 degrees or warmer. 120 days, that's 4 months. May, June, July, August. Every day in those 4 months, it'll be over 100 degrees. Like right now, if we have 3 of those in a row, it's like, my gosh, this is miserable. Think about it. We're going to have, where on our calendar can we fit 120 some odd days of over 100 degrees? That's what we're facing by the end of this century, according to these model projections. Okay, showing the low emissions and high emissions scenario, what this says is that there is an opportunity for change. Right? Often you hear climate change, right? Well, it's out of control. Either we don't have to worry about it because it's a hoax perpetrated by scientists and others, or we don't have to worry about it. Things are so bad, it's just going to happen. There's nothing we can do about it. Well, what this shows is that there is something we can do about it, right? The difference between these two scenarios is human behavior, right? It's nothing to do with the natural system, right? So it's also always important to keep in mind when people say, I'm not going to worry about it, nothing I can do about it. Actually, there is. All right, so now let's go backwards in time. Let's look at droughts in Texas, or one location in Texas over the past 1,000 years. So here on the x-axis, we go from the year 1800 to the year 2100 on the top panel. The bottom panel, we go from the year 1050 to the year 1350. And what's shown here on the y-axis is this drought index, Palmer Drought Severity Index. Doesn't matter the name of the index or these numbers. Negative numbers means it's drier than normal. Positive numbers means it's wetter than normal, right? Here's a little cheat sheet here. Dry is downward, wet is upward. All right, so we look at the red curve here, going back through time. The thick red curve is a smooth 4-year running mean through the data. The actual data are the blue trends that we see. And then the green is the model projections going forward. The CMIPS, Climate Model Intercomparison Project 3 models. It's taking different models, different laboratories, different research institutes have developed different models. And this is a study that integrated all of the models together. Okay, that's what the projections are. So we could see this century, the projections are for a downward trend, or trending towards much drier conditions over time. So we go backwards through time, we could see that there are times in the past when there was some droughts. This was a 6-year drought in the 1950s. Back in the 1860s, 70s, there was a significant drought. And then we go back through time. Look what happens when we get back to the 1200s and the 1100s. There's almost one continuous drought. This drought right here looks like it's about 20 to 30 years. Any drought that's 10 years or longer is called a mega drought. We get into the 1200s. We see that these are even picking up in intensity and length. We go from almost 1,200 to almost 1,300. That's almost a 50-year long period where we were in drought in this region. So all of this data in the past, these observations, this is the instrumental record from 1900 to 2000. And then back before then, it's tree rings that's giving us that information, right? And then the projections are the models, as we talked about, all right? So we got the models going forward, the instrumental record for the last 120 years, and the proxy records or tree rings for back before then. So consider this. This 1950s drought is what's called the drought of record in Texas. It's what's used by the state agency, the Texas Water Development Board, the state agency that is responsible for ensuring that there's enough water for all Texans for all uses. 50 years out is the planning horizon. So what this says is that while you're doing your water planning, make sure you have enough water in whatever region is undergoing planning. Make sure you have enough water so that 50 years out, you have enough should this worst case scenario, this drought of record, reoccur. And so we might ask ourselves here, let's go back to the collapse of the Anasazi civilization in the late 1200s. The archaeologists and anthropologists have come to some agreement. This was a civilization in the Four Corners region of the Southwest U.S., built these elaborate cliff dwellings, were able to channel and through aqueducts water to where they were from springs. In a very dry area, they built an impressive civilization. But eventually, it's widely believed in the archaeological anthropological community that the civilization collapsed because of the extended droughts. So given the past mega droughts, given the projected mega droughts, right? Again, looking forward this century, we see that we're in almost one long drought once we hit mid-century. I ask you, is this sufficiently planning for resilience by using this 1950s 6-year drought as the worst case scenario in our planning going forward? We'll return to how Texas is planning or not for the future. Let's consider the costs of climate change. So let's consider these drought periods. The 2011 drought, which I mentioned, it was 8.7 billion per year. The 1950s drought, it was 3.5 billion per year. And this is all scaled, it's corrected, it's all in today's dollars, taking in consumer price index changes over time. And how about the Anasazi civilization? What cost? How can we monetize the loss of a civilization? That's pretty challenging. The key question is, what is it going to cost in the future for these projected droughts that we're looking at? Where, as I said, we'll have twice as many people living in a region that's now going to experience a multi-decadal scale drought. This is the big question. How can we consider those changes? Let's further consider those costs if we include lost ecosystem services. So by ecosystem services, I mean, if we look at a forest, what kind of services do they provide? If we look at a tree, what does a tree provide for us? Habitat for creatures, food, shade, keeps soils from eroding, sequesters carbon, produces oxygen. These are all filters water. These are all services that ecosystem that tree is part of provides. Well, the cost estimates that are made, like this 8.7 billion, are simply based on livestock losses and agricultural losses. If you factor in the cost of a tree, the value of a tree, and that we lost 301 million trees during the 2011 drought, this actually becomes more like $40 billion. And compare that with Hurricane Harvey, which over 2 weeks wreaked damage on the order of 125 billion. Hurricane Harvey got a lot of media attention, as well as it should, because it was powerful, it was destructive, it was record-setting, and it caused a lot of economic damage. And I think we also have to consider the true economic costs of these slower-moving climate events, these droughts. I think it's important to consider the bottom line on these things, because oftentimes that is a way, when we see what the impact will be to our nation's economy, that will be a way to actually try to evaluate what are the things that is worth changing. Is it worth getting out in front of? Should we wait until it's bad and on top of us? Or what will be the cost if we acted now to try to mitigate and adapt to these changes versus waiting until they happen? In other words, what's the cost of acting now versus what's the cost of taking no action and waiting for these worst case scenarios to occur? Here's another way to look at it. Here's by county gross domestic product change by the end of the century from today due to climate change. This is a study done in 2017. You can see that the warmer, redder colors, browner colors, is where there's more economic damage. And the cooler colors, the bluer colors, are where there's less. In fact, you can see that the cooler colors actually have negative economic damage. That means there's actually economic gains. Might think of for a second, what might cause some regions to gain from climate change? Well, these more northerly latitudes, according to the models from this study, are gaining due to savings of the cost of fuel heating in the winter. Your oil heating bill will be much lower than it would be in present day because it's going to be warmer there. So some places win, some places lose. And you can see the Gulf Coast is a place where we'll receive big economic impacts. And Texas, again, always seems to be, no matter how you cut it, seems to be in a bullseye of these economic and natural disaster impacts. I would add that Hurricane Harvey had not yet occurred when this study was published. So factor that in, and then Texas becomes even more red or more brown. Maybe it would be like flashing. I don't know how to do that in PowerPoint. Make it flash. Okay. So here's a title of a paper that came out several years back, talking about drought risk in the American Southwest and Central Plains. And I remember reading that paper, which was published in the peer-reviewed literature, this journal called Science Advances. And I remember being struck by it, by a particular word in that title. What word do you think struck me after being decades of reading scientific papers as part of my everyday work? I'd never seen this word in the title of a paper. And the word is unprecedented, right? Because that almost sounds like it's got some drama attached to it. Why it's unprecedented what's going to happen. And scientists are supposed to be cool arm's length arbiters, calculators of what the data show and not get into any drama. Well, so I was inspired enough by this that we did a study here in Texas in which we used that same word because we have unprecedented drought challenges for our water resources in a changing climate. And this is a paper published just last year. And I'll give you links to where you can find these papers if you're interested in reading them further. But we used the word unprecedented again, and it was not because it was dramatic or emotional or anything like that. It was really compared to anything we've seen in the past, what we're looking forward to, what we see according to the model projections is that we will have unprecedented droughts. And this will be a huge challenge for us. And if you're really interested in seeing this, all you have to do is Google the term unprecedented with the term Earth's Future, which is the name of the journal, and this article will pop up. Okay, so this is from the first paper, that 2015 paper, and I want to show you in the straightforward way. Again, we have on the y-axis dry down, wet is up. Instead of drought index, we call it here moisture balance. Different ways of looking at the same thing. And on the x-axis, we're going from the year 1000 to the year 2100. Okay, in brown is the proxy record and the instrumental record. This is for the Southwest US, of which Texas was part of this study region. We could see in the proxy record as we go into the instrumental record, and here you can see this brown curve, this dip right here. That's the drought of the 1950s. All right. So we have the instrumental record for the 1900s. We have the proxy record going back through time, and here you can see the 1100s and the 1200s. Remember, that was the area of the Anasazi civilization collapse with those mega droughts, right? Here's a mega drought. Here's a mega drought, the second half of the 1200s. And now let's look at these colored curves here. These are the model projections going forward. 17 different models in the climate model intercomparison project. And now the gray, hopefully you could see it, is the variability between the models and amongst the models, right? So statistically, the models are all different, right? And it's important to keep in mind that my favorite phrase around models is that, or saying about models, is that all models are wrong. Some are useful, right? That models can never get and exactly replicate the huge complexity that nature throws at us. But they can be very useful in helping us look at boundary conditions and how changes in things like greenhouse gas levels in our atmosphere will cause changes. They won't get it exactly right. So it's always important to consider the uncertainty. And that uncertainty is quite significant on these. However, look at the uncertainty at the end of the 21st century here versus, and the mean and the uncertainty versus the mean and the uncertainty where we presently are, right? Those are clear differences. And what's happening is, looking at all those colored models, they're just dropping off the end of the table, heading down at a pretty steep slope to more intense drought and what looks like a semi-permanent drought, right? This is almost an entire 3/4 of a century of drought if these projections come to pass. So how do we put this in context? Well, let's look at what we might consider the most intense drought in the proxy and instrumental record. It's not the 1950s drought. It's actually this one here in the 1100s. And let's actually look at that value now compared to the projections. According to projections, we're like now in the midst of this, and we're actually passing it, on our way to an intense and extended drought that's coming to the same region that we will have a doubled population with increased water demand. So that's what we mean by unprecedented. And you can see that drought, this really puts it in perspective, doesn't it? To now compare it to the quote unquote drought of record, quote unquote worst case scenario that's being used for water planning. It's just not sufficient. So in talking about unprecedented climatic events and impacts in Texas, we had this 21st century projected drought. That's everything I've been talking about, more intense and longer than any in the past 1,000 years. That's what makes it unprecedented. That 2011 drought, for the first time, the Lower Colorado River Authority, which oversees who gets the water out of the river, for the first time since the dams were built to dam up that river, to provide a water resource, for the first time, not everybody who wanted water got it. They denied water. The dams were built in the 1930s as part of the WPA program, put forth by FDR's administration. In 2017, Hurricane Harvey produced 61 times 10 to the how many inches of rain? It's actually 10 to the 0. The question mark should be a 0. 61 inches of rain, 27 trillion gallons of water, most ever recorded in the lower 48. In 2018 rainfall in Austin, we had high rainfall that led to a week-long boil water notice. Our water facility could no longer produce clean water for us. It was overwhelmed by the turbidity that had been produced by that intense fall season of rainfall. It overwhelmed the water utility for the first time since the utility was built in 1926. So that was unprecedented. Both on the dry side and on the wet side, we have unprecedented events. For the first time in 2019, we had 4 consecutive years with Category 5 storms in the Atlantic Basin. And in 2019, we had our warmest September ever. In 2020, the data came in about a week or so ago through NOAA. It was the second warmest year on Earth since record keeping began in 1880. It was the world's 7 warmest years have all occurred in the past 7 years. A record number of tropical cyclones, 103 named storms occurred around the world in 2020, tying the record previously set a couple of years before. And I pose this question, how does any of this fit with what we said at the outset, what climate science predicts about the effects of a warmer atmosphere? Every one of these unprecedented things is fully consistent with what those predictions are from climate science, from the basic physics how climate science works. No one of these things, you can't point to any one of these things and say, aha, this is a result, this is due solely to global warming. However, you can look at this all and say collectively, these are all fully consistent with what climate science predicts will be a consequence of global warming. And here's a line at Costco for buying bottled water. That's all people were in line for bottled water during that fall of 2018. You could see the lines stretching all the way out here, wrapping all the way around, coming back here, and the line had to be overseen by police. What kind of society might we be heading to? Okay, so I want to go through really quickly to wrap up policy at the state level, policy at the federal level, and what kinds of things we might be able to do about this. So the legislature in Texas meets every other year. In 2009, there was a bill that was introduced. I was asked to testify on the bill. So I don't have policy background, but I am sharing with you my own personal experience related to policy. This bill would require 14 state agencies to take climate change into account in their planning. Right, the Water Development Board, that state agency I've been talking about, Texas Commission on Environmental Quality, Parks and Wildlife, Forest Service, right? All these agencies that you think would be impacted by climate change. Right? And what the bill said was, when you're doing your planning, make climate change one of the things that takes into account. The bill would require no new costs. I found out by sitting in the legislature all day. I was told to be there at 8:30 sharp. I was there. I was asked to testify after 6 p.m. that day. I was early and I was wearing a suit, and still, it made no difference. I waited all day, and I learned a lot of things that day about how the legislature works, including that every bill has to have a fiscal analysis. This bill would require no new costs. Why? Because all these agencies undergo regular planning anyway as part of their charge. All it's saying is when you're doing that regular planning, make climate change one of the things you take into account. In my opinion, this seemed like a fairly innocuous first step we might take to be ready for the change that is coming our way. I'll share with you the testimony. I'll be real brief about it. I have some videos. I won't play them about the testimony. I gave testimony, basically what I've been telling you. Someone followed from a conservative think tank called the Texas Eagle Forum, and they said, we believe humans have nothing to do with the weather outside, and they went on to say other things. So testimony, I was testifying on the bill. They were testifying against the bill. Some people were testifying for the bill. At the end of the day, here's a set of actions that occurred on the bill from the time it was received in February 19th by the Senate of Texas, all the way to his testimony was taken in committee in March 19th. That was a day of my life I will never get back. It failed to receive an affirmative vote in the committee a few weeks later, and the bill then did not come to pass. It was voted down. That was in 2009. As I said, the ledge in Texas meets every other year. This same, pretty much verbatim, the same bill has been introduced every other year. And I've been asked to testify on it every other year, and it has failed every other year. Maybe 2021 will be different. That's what's happening at a state level. Again, I told you at the beginning, is this sufficiently resilient planning that the state is undertaking? Here's this figure I showed you before, and this is a quick interactive way to look at what we might call a thumbnail guide to Texas planning. So you're actually going to have to use your hands for this. I want everybody to be interactive on this. So with your right and left hand, make a right angle between your thumb and your fingers like so, and slide your thumbs back and forth, and cover up the bottom panel with your thumbs. Then move your right and left hand back and forth until you block out the green with your right hand and block out everything from 1900 and older with your left hand. If you've done this correctly, all you could see through your hands is from 1900 to 2000. And that's because that's what the Texas state legislature takes into account in planning. State level planning is done only by looking at the instrumental record. It ignores the projections going forward, and it ignores the proxy record from the past. Clearly, we need to make better progress if we're going to be ready for the changes that are coming. So that was my opinion, that last sentence. Everything I said before then was sharing data with you. Really separate observations, data, from opinions. All right, at the federal level, what's being done? Well, there was this national climate assessment, and the New York Times called it the most comprehensive scientific study to date, detailing what will happen with warming on the U.S. economy, public health, etc. Congress mandates that the NCA, because this is a government-funded reporting, that every 4 or 5 years that the NCA, National Climate Assessment reports, are published by the White House. When they did this back in the mid-90s and they started this, they thought this would be a way to ensure a high profile of this report. However, this year we were done with our report around late February 2018. It wasn't released until the day after Thanksgiving. Why? The White House was quite straightforward with it. They said, we don't believe in this report. We think it's wrong. We think it's wrong intentioned. We think there's lots of problems with it, and we don't want the public to see it. So we waited until Black Friday, the day after Thanksgiving, to release this, because no one watches TV or the media because everybody's doing Black Friday shopping. Right? And Steve Malloy of the Trump administration called the NCA report a product of the deep state. Some of you may be following lately. The deep state has become more in the news lately for a variety of reasons, right? But this is a cabal of people working to undermine all that is good about this country. So as I told you earlier, and as Brian mentioned at the outset, I was one of the co-authors, one of 300 co-authors on this. So if you have not yet met someone who's a member of the deep state, apparently now you have. So that's state, federal, and this quote here is basically saying maybe there's hope in municipalities because national governments are set up to defend their interests. Cities are not. Cities share. Cities are one of the few organizations in the world that freely exchange info so they could share best practices. Right? Companies don't do that. That's their competitive edge if they share. Federal governments don't do it, but cities do. So cities tend to be more innovative and progressive around this, and maybe we could place some of our hope in that. Maybe we can expect some change with the new administration in Washington. We're happy to talk about that. There are some obstacles we certainly will continue to face, even with the new administration. So again, the takeaways are that Texas has climate changed in unprecedented ways, and it's going to change in more unprecedented ways in the 21st century. At the same time, the population will double. There'll be multiplicative impacts from many sectors on our resources and our quality of life. And new research approaches and education approaches are needed to address these challenges. All right, thanks for your attention. I'll be happy to answer questions. Excuse me, I guess this is going through the chat. And I'll also give you my email address if at the end of the chat you want to further ask questions of me. And then also here are other resources, publications, including the ones that I cited during the talk, the Environmental Science Institute at UT, and a really cool program that Brian Flynn also knows a lot about called Hot Science Cool Talks. If you're really interested in being engaged and wowed by science, you should look these up. And if this goes away, just type in hotsciencecooltalks.org into your browser and you'll get there. Okay. I think what I will do now is, I guess we'll take questions. So I'll go into the...
Yeah, Jay, let me say thank you very much for your presentation.
Sure.
It's a pleasure to listen to you speak on this or any other subject. While the question should be put in the attendee chat box if you want, if anybody in the audience wants to put forth a question. While we're waiting for those, let me kind of ask a question, Jay. Is it accurate to say that when we had the drought back about 10 years ago in Texas, that the legislature's response to that eventually was a $2 billion revolving fund for backstopping the funding of state and city and county projects around the state for expanding water resources? Is that fair? It's fair to say?
Yeah, absolutely. To help, with infrastructure, right? We could build more reservoirs. We can't build more dams, right? Every river has been dammed all the way in Texas, but we could build new reservoirs. We could invest in new technologies, some like desal, aquifer storage and recovery. We're doing very wet times. We can channel all the overflow water into aquifers, so we could store it in a bank, like the Edwards Aquifer here in Central Texas. So during lean times, we could have more. But you think about it, building more reservoirs. If if it's not raining, if we're in an extended drought, then we can build all the reservoirs we want, and it's not going to make a difference if we're not getting more water falling from the sky into them.
Right. I think we've got questions coming in.
Yeah, right. Thanks. So the question comes from Brad Shanks. How do you define higher temperatures, higher daily highs or higher daily lows? So those long-term temperature trends, like 100-degree days and whatnot, right? Those are just high temperatures, right? That would be a daily high on that. But you'll also see climate models projecting out like global average temperatures. Annual average temperatures is another way that the models present their results. So it can be done many different ways depending on what question you're after. Thanks, Brad, for that question. Well, I know there are actually lots of other good questions that you would have out there. I've given this talk a number of times and always had the questions spill over to follow up by emails afterwards. So you guys are welcome to do that. But if you have a question,
if I could just interrupt. I'm sorry, Jay. There's a couple questions hidden. It's up top. There's a speech bubble. There's actually 2 spots where attendees can ask questions.
Gotcha. I see the other spot now. Thanks.
Okay,
So the question is, excuse me, from Michael Kavanaugh. Michael asks, great talk. Thank you. What are the top 3 things that you would recommend for resilience in the apparent inevitable changes? Yeah, that is the $64,000 question. I'm dating myself by using that term. That was a quiz show from, I think, the 1950s. The top 3 things you'd recommend for resilience and the changes. So in the case of Texas, right, I think it'll come from a number of areas. So I'll say top 3 areas. I'm going to cheat because that's going to allow me to put multiple things into each area, right? One is technology, already in response to Brian's question, right? There's lots of things we could do technologically, right? We could desal both seawater. We could desal from oil and gas wells, right? Oil and gas wells also produce water quite commonly. That water is less salty than ocean water. And so it requires less energy and money and a lower carbon footprint to desal water from a lot of these oil field production wells. That will help, but right now those processes are costly in terms of money. The technology is always improving. We have some great research at UT Austin on membrane technology in the College of Engineering. But these things are costly, and it costs energy to push salty water across membranes. And so, are you saving the water cycle? And then by doing that, you're trashing the carbon cycle, right? It's a bigger carbon footprint. But I'm confident technology will always improve and get more efficient. Certainly, we could use many more renewables. Texas has done a great job in wind and doing a good job in solar. There's always opportunities for more of that, making more investments in that. So I think there's no doubt we have to transition away from a fossil fuel-based economy as soon as possible to a renewable-based economy. So investing in that end of technology, and the other technology are things like these creative things like aquifer storage and recovery that I mentioned. Another area of change, I think, recommending for resilience is policy, right? We could come up with all the technologies, but if we're not legislating, right, or not having incentives, financial or otherwise, for these things to be adopted and used, we may not get there. So the policy area, I think, is another big area. And then there's a lot of personal conservation. I think we could learn to do with a lot less water. We should be prepared for that. Here's a crazy thought. I think everybody sometime in their life should be required to go camping and pack in all the water you need for 4 days. And you'll get a real sense of how valuable water is, how little you could use to do things like brush your teeth. And once we start valuing water, I think, it changes our own personal conservation. But the biggest thing I want to end with is, I think the single most important thing, if there is one, it's not the only thing, but if you say which one's most important, I'd say education. I think people have the state of science, technology, engineering, and math, or STEM education in this country is nowhere near where it should be. And if we could revolutionize that and put the resources needed into making it very engaging, then I think every citizen would be scientifically literate enough to understand these changes that are coming and making good decisions, whether it's personally or in the voting booth, right? And I think it would also get us away from a lot of the challenges that we're facing. That, for example, how we're dealing with this pandemic. I think if we just listen to science-based reasoning, we wouldn't be in this state we are. Okay, that was opinion, but thank you, Michael. I think you kind of asked me for my opinion. So I had my opinion hat on for that one. Next question comes from Steve. Thanks, Jay, for presentation. You're welcome. Thank you. No mention of sea level rise and implications on cost impact and loss of land. Absolutely. It's another synergistic challenge Texas faces, right? It's on the Gulf Coast. Sea level is rising. Land is being used up and eroded. The encroachment of the salt water from the oceans on underground freshwater aquifers is big. The loss of land, the loss as sea level rises by the end of the century. The projections are most of the barrier islands that we enjoy vacations on along the coast of Texas will be nearly completely flooded, or at least there'll be such little land sticking out above the ocean that the protection against storm surges from increased tropical storms. There's another example of those synergies, right? The warming is leading to the rising sea level. It's reducing the protection of those barrier islands that they afford if they're gone against the tropical storms. Tropical storms are also being caused by the warming, right? So those are some positive feedbacks leading to very negative impacts on our land. Let's see, the next question. Sorry, I can't quite get the whole thing in my view. Maybe this comes from another question from Michael. Thanks, Michael. Maybe the emigration of California residents to Texas will result in approval of the bill you supported. Maybe. I lived for 4 years in California before I moved here. I was originally from the Northeast. California, certainly, I think you could point to California as a state level and municipal levels that have been quite progressive in bringing about changes. But maybe people who are emigrating from California, maybe they're tired of the restrictions they're under and are coming to Texas because it's the land of the free. I don't know. We can only hope that it'll have the effect that you're suggesting, Michael. Thanks for those questions.
Marissa, if you're on the line, are we doing a survey of the viewers of this presentation to get their opinion about how well it was done?
Yes, that will be at the end when the whole presentation is over. That a screen will pop up after the presentation is over. There's actually 2 more questions to the left in the attendee chat.
Okay, thank you. I see it now. Thank you, Marissa, for keeping us honest here.
Of course.
Mike Selna, what programs does Texas have underway related to water reclamation and reuse? Thank you, Mike. Great question. I think gray water, reuse of water, like you wash your hands. You guys know this, right? Sorry if I don't mean to be talking down to you, but gray water, like we wash our hands, it goes down the sink. I think so much can be done with that to reclaim it and to reuse it. And I think we're at a really important time, because if we're going to double our population, that means we're going to have all these watersheds that are developed, landscape developed with new developments, new housing developments, new industrial developments, right? Where are 26 million new Texans going to live? We have to build new things. So right now, I would say one thing that holds up gray water reuse is people say, well, it's too hard. You got to hire, let's say the simplest thing. What I want to do is when I wash my hands, I want that water, instead of going down to the water treatment facility and all that energy that's involved in it, I want it to just go to my toilet tank and fill it up. Right? So do we have to really flush our toilet when we go to the bathroom? Do we really have to pee in drinking water, quality water? That's what we're doing now, most parts of the world. All the energy and effort and money that goes into cleaning up the water and we put it into our toilets for us to pee into. That's crazy. Why don't we pee into gray water, right? So I want to see the water after I wash my hands go to my toilet tank. So right now what I have to do is probably hire a contractor to knock a hole in the wall, put the pipe through, right, and connect those things and put in a check valve so there's not backstreaming, all the rest. But if it's expensive to do that now, so most people don't do it. There's very little incentive to do it. So I think we could change by having incentives. But moreover, if we're going to, as I said, have all these new developments where 26 million new Texans are going to live, then if you do it from the scratch, on the blueprints, that's just putting another little piece of PVC pipe on the blueprints in a check valve. That's like pennies. That's next to nothing. So I would see, why can't we have incentives to, even if it requires legislation, to legislate that every developer has to show how they're reclaiming 3/4 of gray water for reuse. There's countries in the Middle East like Israel that have been dealing with lack of water forever, and they're easily doing those levels of gray water reuse. Thanks, Mike, for that question. Next question comes from Austin Milligan. I believe the majority of water in the U.S. and probably Texas as well is related to farming and agriculture. In the bills you spoke about when testifying before the Texas Congress, were there any mention of changing farming methods to use water more efficiently or change crop choices? If not, could this be something to look into? Certainly, the ag sector is a big user of water in Texas, no doubt. Those bills were crafted by the legislators to be as innocuous as possible. So they were not going after any particular sector, ag, industry, domestic, water use. They were just saying climate change is something that we should be concerned about and take it into account in whatever planning you're doing. And so there was no prescription on how the Department of Agriculture should take it into account, how the Water Development Board should take it into account. They're just saying, you guys are the experts, make sure climate change is part of what you're doing. And I would like to see even more teeth being put into those bills. But as innocuous as they were, they're still not getting any traction in the legislature. And I think it's because there is, you look at the history of the legislature, they're not really big on, or just really not accepting of the realities of climate change. And so that's a big obstacle. So I think the legislators were trying to make it have not that big a bar to entry to it. Thank you, Austin, for that question. And another question from Mike. I was thinking more on the municipal scale in terms of reuse. In LA County, we have over 200 million gallons a day of reclaimed water produced that is used for irrigation and also for indirect potable use. Yeah, absolutely. Whether it's on the home scale, but I think we are going to be building cities out. And so that's the case I was trying to make there, Mike, was if you could legislate that all new developments have to have this, then that's an easy thing to engineer in from the beginning. But I also absolutely think we have to have things on the scale like in LA County. I think they call it, don't they call it poop water? Or is that in El Paso? I get them confused sometimes. But basically taking wastewater or poop water and reclaiming it, cleaning it up, and actually using it for irrigation, but also for sometimes potable uses. Absolutely. And for me, the bottom line is we have to be looking at all of these efforts: technology, conservation, personal change, legislation, and education. I think there's no one silver bullet that's going to answer it all. I think we have to throw the kitchen sink, everything we have at this kind of problem.
I think that's it for questions. Brian, do you have anything else?
No, I greatly enjoyed it. And I thank everybody for joining and listening in and watching today.
Thank you all for your
much.
Thank you very much to Dr. Jay Banner, UT, for doing the presentation.
My pleasure. Thanks for your engaging questions.
Thank you, everyone. Have a great day.
So long.
Bye.
Bye.